Each week, a group of educators and mathematicians get together and play with a puzzle or problem that might work well in the classroom. This week, Daniel Hodgins and Mason Phillips presented the puzzle about Smileys. So in this puzzle, you have a canvas and you proliferate it with a few smiley faces, and then you start the algorithm running. At each step, if an unhappy face is beside two happy faces, then it flips over. It becomes happy. The first question is, how many happy faces do you need to completely fill the whole canvas? The second is, and this was really the focus of the incubator session, is what is the longest it takes to fill the entire canvas. So that's what we're going to be playing with today. This is an app that you'll find on Julia Robinson Mathematics Festival website. And you can go in there and you can select, we're going to do it on a 10 by 10 canvas. You can select these smiley faces and then hit ready, and you're going to see how long it takes. The first group played around with this algorithm. They saw it as just increasingly going up and down in increasingly long lines. And they come up, you can come up with it yourself, you can come up with the algebra behind that, and you can see how long that takes for a certain canvas. That's a beautiful exercise for your kids. The second group thought that they could do better than that. Now, actually, the groups are working independently, so I'm just presenting them in this way. So the second group did even better. They presented it in a way that you take the entire line. You go as far up as you can and then come all the way down, as far up as you can. But they only fill, unlike the first group that filled thickly every line, this group could only fill 2/3 of the lines as you went across. Okay, see the way that works. The last group, which didn't exist, but afterwards I was thinking that these two groups together probably have the right idea. And so this is an even better result that you can algebraically show is significantly better than the other two once you get to a large enough canvas. And a large enough canvas, coincidentally, is 10 by 10 and larger. Here's a summary of the results for the 10 by 10 canvas. Here is the triangular solution of the first group, the second group's full height solution, and the optimal hybrid solution. The optimal hybrid solution is even more obvious whenever we look at a larger grid. So we're going to look at a 14 by 14 grid. Even though the app currently doesn't go there, I've faked it. So this is what we're going to find. We're going to find that the optimal is 127 steps. And here goes. I chose 14 by 14 because it was obviously really good for the hybrid solution, but that's not always true. Here is the 15 by 15 canvas, and you can see that for that this has 149 steps with the long solution, the high solution. This is a hybrid solution that has less. Why is that? It's because the last column really doesn't add anything. Even if we add a smiley face to it, it doesn't add to the length. If we move out so that we have more of that first triangular part of the solution, then we're only up to 145. And the optimal, we just tie. We don't exceed. We just tie the high solution. Anyway, thought this was interesting. Enjoy, everyone.